Hi everyone, this is Erin, and I'm going to present my lesson plan for our project this week. I'd like to begin by explaining that I was inspired by a lesson plan, actually called a Maker Challenge on teachengineering.com that I saw called Cool Puppy, and that I also used CK12 for information about thermal energy transfer, which I also used in my lesson plan. So, for this project, I decided to focus on sixth grade, and the topic is to design to minimize thermal energy transfer. And it is a two-lesson series. So, a description of this lesson is that the students will use what they learn about the engineering design process and thermal energy transfer to design a doghouse for a puppy that minimizes thermal energy transfer in the summer heat. And this uses performance expectation MSPS 3-3, which is to apply scientific principles to learn, to design, construct, and test a device that either minimizes or maximizes thermal energy transfer. The three specific learning outcomes of this lesson are students will be able to apply the engineering process to design a solution to a problem. Students will be able to explain radiation, one of the forms of thermal energy transfer. And students will be able to describe the difference between thermal conductors and thermal insulators. This will be based on students' prior knowledge of thermal energy transfer, the three types of which are conduction, convection, and radiation. So for this lesson, the science and engineering practices that are engaged are to construct an explanation and design solutions. And they're going to apply scientific ideas or principles to design, construct, and test a design of an object, tool, process, or system. The disciplinary core ideas include temperature as a measure of the average kinetic energy of particles of matter. The relationship between temperature and the total energy of a system depends on the types, states, and amounts of matter present. Also, energy is spontaneously transferred out of hotter regions or objects and into colder ones. Including the more precisely designed task criteria and constraints can be defined, the more likely it is that the design solution will be successful. Specifications of constraints include consideration of scientific principles and other relevant knowledge that is likely to limit possible solutions. And finally, there are systematic processes for evaluating solutions with respect to how well they meet criteria and constraints of a problem. And the cross-cutting concepts that are engaged in this lesson include energy and matter, and that the transfer of energy can be tracked as energy flows through a designed or natural system. So some of the preconceptions or misconceptions that we'll be trying to manage with the students is that some of them might think that they should simply start creating the doghouse. But part of this lesson, a major part, is teaching students the engineering design process and having them go through that process consciously when creating their solution for the problem that they're going to be posed with. And we're going to have the students do that by giving them the engineering design process worksheet and reviewing it with them. So how will this lesson actually be introduced to the students? An engaging opening. It'll begin with a guided class discussion. We're going to ask the students to imagine that it's the middle of summer, and what if they had left a chocolate bar in their car all afternoon on a sunny day? And we ask them, well, what would happen? And we anticipate that the students would answer that this chocolate bar would melt from the heat, because this is something that's probably happened to many of us before, where something is left in the car in the heat and we discover some kind of a mess. We then ask the students to imagine it's the middle of summer and their car has leather seats and has been parked out in the direct sunlight for hours. And what would happen if they were wearing shorts and they got into the car and sat down? We anticipate that the answer is that the students would know from their own personal experiences that the seats would feel like they're burning because leather absorbs heat very rapidly and strongly. So they would feel the burning of that leather. It's something that they would not enjoy experiencing. And based on the students going into their prior knowledge and their prior experiences, we then express how it's very dangerous during the summer. Sometimes in a car, you can't leave pets in a car. You can't leave children in a car during the summer because it becomes extraordinarily hot. and it actually is dangerous for any like living person or animal to be left in a car that doesn't have its air conditioning actively running. Someone could become dehydrated and it could actually be deadly. And we'd ask the students, can anyone explain why cars become so hot in the summer? And we anticipate that the students will realize it's because during the summer, the sun is more powerful and the heat from the sun heats up the car tremendously in that enclosed space. And we would demonstrate just how powerful the sun can be, because that's a very particular situation, but how powerful the sun can be during the summer with this video called Frying an Egg on a Sidewalk, where they can actually see the power of the heat of the sun during the summer.
All right, right now we're going to see if it's actually hot enough to fry this egg on the sidewalk here in Arizona. We're in Florence. It's about 117 degrees. Look at that. It is cooking. Oh my God. Don't zoom in too much.
So students, of course, know that during the summer it gets very hot, but hopefully with reminding them of how hot it can become in a car, how it can be dangerous for a person to be in a car during the summer for a long period of time, by seeing how powerful the sun, by seeing that egg actually cook on the sidewalk, we would engage with them and help them understand, introducing this idea of thermal energy transfer, something that they've learned about before, but reintroducing it to them and reminding them how powerful it can be. And we would be trying to ask the students and get them to the point where they recall from previous lessons that one of the particular forms of thermal energy transfer is what's happening when the sun is heating up the earth during the summer. There are three types. There's convection, conduction, and the one that is actually happening in the experience with the sun, radiation. And we would actually give the students, remind them of the formal explanation or definition of radiation, which is the transfer of energy by waves that can travel through empty space. When the waves reach objects, they transfer energy to the objects, causing them to warm up. This is how the sun's energy reaches Earth and heats its surface.